That was really loud. Okay, all right. Okay, guys, welcome back to another beautiful day. Today we're going to go through the final chapter of thermal physics, guys. The final chapter of thermal physics is basically teaching you the three main processes where heat could be transferred, guys. Now, I think some of you guys may have learned this in year 9, but essentially these words are no strangers to you, right? There are three main types of thermal transference. The first one being conduction, the second one being convection, and the third one being radiation here. Now, to somewhat understand conduction, convection, and radiation easier, right? It's always good to start off with a story time, okay? So let's imagine today, you guys just finished your exam and you and a bunch of friends have decided to go camping somewhere in the mountains, right? So when you go camping somewhere in the mountains, obviously, what's the first thing you're going to do when you reach the camping site? You're obviously going to start fire, right? And the fire will usually be in the middle of the campsite. Okay, so let's imagine there is a fire here. Okay, so let's imagine there's a total of 3 of you guys, right? The first guy who is super damn hungry, the first thing, as soon as the fire starts, he wants to start roasting his marshmallows already. Okay, so as he roasts his marshmallow, because he is somewhat of an idiot himself, right? So what he did was, right, he decided to poke his marshmallows into a metal rod here. Okay, let's imagine there is a metal rod here, and the end of the metal rod, there is a marshmallow. Okay, so this is person number 1 lah. Then person number 2, he's a little bit afraid of the cold. So what he does is he likes to stand right above the fire. Oh, let me use a different color. He likes to stand right above the fire, and then he wants to put his hands above the fire. You know, like you put your hands right above the fire so that your hands get a little bit warmer. This is the second guy. Okay, he's receiving heat through the fire. And the third guy is super damn lazy. As soon as he finished the hike up the mountain already, he feels super damn tired. So what he did was he started curling into his sleeping bag and started sleeping already. So he slept right next to the fire, like a certain distance away from the fire, which is obviously safe. Now, each and every one of them, they are actually receiving heat from different processes, essentially, right? Let's go for the first person here. Now, Leha, if you were to take a wild guess, in terms of heat transference, how do you think this guy is going to get heat from? Is he going to get heat from conduction, convection, or radiation? Leha?
Conduction.
Good, excellent. This guy is essentially going to get heat through conduction. Why conduction? Because if you think about what's happening here is as soon as the heat starts roasting up the marshmallow, because this is a metal stick, right? And we know for a fact that metals are generally good conductors of heat. So what's going to happen is as soon as the heat starts rising here, the heat will be conducted through this metal and eventually burn his hand. Now, for conduction to occur, guys, conduction can only occur in a solid object or also a liquid object here. Essentially, conduction occurs because the heat that is transferred to this marshmallow is conducting the energy from the hot end all the way to the cold end and eventually heating his hand. Now, usually for conduction to occur, guys, it must involve a third-party object. Okay, in this case here, the third-party object will be essentially the metal stick, because the heat will heat through the marshmallow, heat through the metal stick, only then it will reach your hand. So in this case here, the third-party object is essentially this metal stick here. Okay, so always remember, guys, conduction is basically usually occurring in solids and liquids, and it will always transfer from the hot end to the cold end. It requires a third-party object for it to get heat. Okay, then the second guy here, which is this purple guy here. All right, Chihin, which way do you think this guy is getting heat from? Conduction, convection, or radiation?
Radiation.
Radiation. Why radiation?
because convection is only liquid.
Not exactly. You're very close. Okay, now let me clarify that. Basically, this guy here is getting heat through convection. Why convection? Is because for convection to occur, right? Okay, it will happen in a liquid, but it could also happen in a gas as well. Essentially, every time when you put your hands above the fire, do you notice that when you put your hands above the fire, the heat is actually the most intense on top? Why is this occurring? It's because if you recall back from the previous chapter of 2.2, we learned that heat expands and cold contracts, right? So what essentially happens here is, right, this heat is actually going to heat up the gas particles above it, right, causing its volume to expand, and thus the density drops and causes the heat to rise upwards here. For convection to occur, guys, usually convection's characteristics is that it usually states that heat only travels upwards, right? It states that heat usually travels upwards. That's why if you ever played with fire before, if you put your hands on the side, you put your hands on the other side, or you put your hands on top of the fire, you usually notice that heat is actually most intense on top, because these are essentially the convection heat coming upwards. Always remember that for convection to occur, heat must always travel upwards. Okay, that is the reason why usually on top of the fire is where it is the hottest. Okay, so the final one here obviously is going to be radiation, right? Radiation is one of the most special form of heat transference, because radiation states that heat can actually travel in all different directions, and whenever we talk about radiation, right, the first thing I want you guys to recall back is essentially heat from the sun, right? It doesn't matter which position the earth is, right? Let's imagine this is the sun and the earth, right? Doesn't matter which position the earth is rotating around the sun, radiation can still be able to provide heat to whichever position the earth is, right? And in this situation here, whenever we talk about radiation, I want you to think back that heat travels in all directions. And in fact, radiation is the only form of heat transference that can travel through a vacuum. Okay, a vacuum, for those who do not remember, is essentially a space void of any particles. There's no solid, no liquid, no gases, right? This is what we call a vacuum, which in this case here is outer space, right? That's why you see the astronauts, when they go to space, they need to wear those kind of oxygen helmets, right? Because if you go out to space without those helmets, there's no air, then obviously everyone is going to die, right? And this is also one of the reasons why this guy is sleeping right next to the fire, because although the heat intensity is not as much as the one that is going upwards, there will still be some form of radiation that is coming out from the heat, which is just enough to warm the guy that is sleeping, to keep warm enough in the mountains, right? And that is the reason why he chooses to sleep beside. Whereas this guy who wants immediate fire to put his hands on top, usually when you put your hands on top, the heat will travel the fastest, and that's why whenever you're burning something, you put it on top of the fire, right? Because that's where it burns the fastest. Radiation is like a byproduct of all the heat, it's just like radiating it a little bit outwards only. Okay, so this is essentially conduction, convection, and also radiation. Always remember that radiation is the most interesting one. It is the only one that can travel in a vacuum, guys. All right, before I proceed on, guys, anyone don't understand anything from this story, or you have any questions at the top of your head you want to clarify with conduction, convection, and also radiation?
If radiation can travel all directions, that means all three people got radiation.
Yeah, in a way, yes, correct. The main form of heat transference for this guy is going to be radiation. This guy, on top of his conduction through the metal pole, he will get some heat radiated outwards as well. And on top of this guy getting heat from conduction, he'll receive some form of radiation towards his body as well. That's why whenever you walk to anything that is hot, you still feel that, you know, like if you ever play with like a big fire, I don't know if you guys ever done this before, but some traditions, they like to, you know, like during Qingming or whatever, they like to burn a lot of those paper money kind of things for the ancestors on, right? If you ever stood beside the fire before, even though you're not on top of it, you still feel that the heat is radiating towards you, and it's because heat can travel in all directions, but just that convection states that most of the heat travels upwards, some of the heat is radiated towards the side only. You get what I mean?
Yeah.
Yeah, but yeah, that's a good question. Every one of these guys will essentially get a form of radiation, but not the main source of heat transfer. Okay. Anyone else got any questions with regards to this at the top of their head? Hey, by the way, Jihin, which chapter is Wesley right now? Are you guys on this chapter already?
They started wave.
Oh, started wave already. So fast. Oh, okay. Yeah. But anyways, after we're done with this chapter, which is the last chapter of physics, the last chapter of thermal physics, like your general physics, we will go through an exam. Then this way I can tell how much you guys know and how much you guys don't know. Please guys, probably in the next 2 or 3 weeks, we'll be having a test on the heat chapter. Please revise your understanding on this, then don't fail my paper. Okay. So anyways, looking at the statements here, now everything will be a little bit more clear. There are 3 types of thermal exchanges or thermal transfers, right? Conduction, convection, and radiation. If you look at this diagram here, this is a simple example of how conduction, convection, and radiation is occurring. You see that this guy here is holding the metal end of the pot, right? So the heat will be conducted from here, conducted upwards to here, and then essentially conducted to his hand. In this case here, this part will be the third party object, right? Now this is essentially convection. Convection states that heat will always travel upwards. That is why, guys, if you take notice of this diagram, you'll see that the lower part is red and the upper part is blue, right? It indicates that the hotter region here is actually going to go upwards, causing the colder region to go downwards here. This is essentially something that is known as convection current. I'll go more in detail on this later on, guys. And finally, of course, radiation states that heat can travel in all different directions as long as you're close enough, right? If you're close enough, heat will be able to radiate towards that specific person or thing or whatever. Okay. Now, today, if we talk about a little bit more about conduction here, let's go through the statements here, guys. Conduction is a transfer of heat in a solid or a liquid, usually involving third-party objects. Different materials will definitely have different conductivity, right? For example, we know for a fact that metals are generally much better conductors. That's why they heat up much easier, right? And then good conductors are usually objects like metal, all right, as heat is easily conducted. Now, guys, in your IGCSEs, whenever they talk about heat being easily conducted or electricity being easily conducted, the reason why metals are good conductors of heat and electricity is simply because they are free moving electrons inside the material. For example, if let's say today I have a metal stick here versus a wooden stick here, a metal stick versus a wooden stick here, right? What's going to happen is, right, essentially these metals, they have free moving electrons that are able to move around in this metal itself, right? And because of these free moving electrons, they are easy to transfer heat and also electricity. Whereas wooden blocks are right, they will have electrons as well because all things are made of atoms and electrons and whatnot, right? Just that the main difference is that these wooden boards, the electrons are already stuck to that specific spot, meaning to say they are not free to move, guys. And because they are not free to move, it is much harder for them to transfer energy or transfer electrons around it, and making them not good conductors. In other words, they are known as insulators, guys. If you look at this statement here, bad conductors are essentially called insulators. Examples of insulators include rubber, plastic, wood, glass, sand, all these things that generally do not transfer electricity and heat are known as insulators, guys. All right. And of course, heat is not easily transferred in them, right, or conducted. Examples of good conductors and insulators include iron, aluminium, copper, which are essentially all the metals, right? And examples of insulators include wood, plastic, sand, and many, many more, right? Wool, all those kind of things is also considered a good insulator, whereas they do not transfer heat, guys. Right? Yeah, anyone's got any questions with regards to this part here before I move on? Good. And then moving on to this next page here, this is basically just a very simple experiment to test which metal is a better conductor and which metal is essentially not such a good conductor. If you just look at the setup of this diagram here, guys, let me go through it one by one. Basically, we have a Bunsen burner here, right? This Bunsen burner is essentially heating up 4 different types of metals. Now, even though we know for a fact that metals are generally much better conductors of heat, right? Different metals will generally have different conductivities. It's the same reason like how we learned about specific heat capacity last week, right? Different metals will have different specific heat capacities as well, right? So because we are heating up these 4 different metals at the same time, right? At the other end of the metal, we actually stick a layer of Vaseline. Vaseline is essentially something like the candle wax kind of thing, right? And then on the end of the Vaseline, we stick a drawing pin here. So the concept of this experiment is very simple. As soon as we start heating up all these 4 different metals, right? Heat will conduct in these metals at different rates, and whichever one is the best conductor of heat, right? The heat will travel the fastest, melt this Vaseline here, and cause this pin to drop. In other words, right, whichever metal has the drawing pin drop the fastest, that is essentially going to be the best conductor of heat. Give me a minute, I guess. So looking at this experiment here, right, is essentially just trying to play around with whichever one is the best conductor. In conclusion, whoever can drop the drawing pin the fastest means to say that heat was conducted onto them the fastest, and in other words, they have the best conductivity, right? So if you look at these statements here, all metals are heated with the same heating source at the exact same time, right? Copper is essentially going to be the best conductor, followed by aluminium, brass, and lastly steel. Why? Because copper only took 73 seconds for it to have, melted the Vaseline and dropped the pin, whereas steel took a total of 340 seconds to melt and drop the Vaseline. So we know for a fact that copper is going to be the best conductor. Steel is actually one of the worst conductors among the metals. Okay. So, yeah, anyone's got any questions from this part here before I move on to the molecular structure of how conduction occurs? Excellent, 100% absorption rate. So if we move on to this next part here, this next part is essentially explaining how conduction occurs in a metal, guys. If you just look at this diagram here, right, I want you to imagine that this right now is the metal pole, okay? And on this metal pole at this bottom end here, I'm essentially applying heat onto it. Okay. Now what happens is, right, as soon as I start applying heat on this other end of this metal pole here, I'm essentially supplying energy to these molecules here, you know. And because we know that solid particles, they do not move around. Solid molecules, they are stuck at fixed positions. But when I supply energy to it, what's going to happen is these molecules will gain energy and start vibrating even more at fixed positions. And because of this vibration, right, they will essentially vibrate and pass on energy to the adjacent molecule here. When they vibrate and pass on energy, 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 vibrate and pass on energy again, this essentially occurs as a transference of energy and heat. You know, that is the reason why, right, for conduction to occur, usually it will go from the hot end all the way until it reaches the cold end, is because the energy is slowly vibrating and passing energy to the adjacent molecules here. It'll start off from the heat source, vibrate, pass energy, vibrate, pass energy, vibrate, pass energy, vibrate, and so on and so on. So this is the concept of how conduction occurs in a solid, you know, is usually through the vibration of the molecules passing energy to one another. So if you look at these statements here, right, as the bar is heated, the particles tend to vibrate more. As you heat it up here, this thing is going to vibrate even more. Thermal energy is transferred from the hot end to the cold end. It will always go from the hot end to the cold end here, as the particles pass on their increased kinetic energy to other particles along the bar. So essentially, you provide energy, vibrate, pass on energy, vibrate, pass on energy, vibrate, pass on energy, and so on and so on and so on and so on. So this keeps occurring until all the way the hot end reaches the cold end, and eventually the cold end becomes hot as well. This is how conduction occurs, guys. Very important. Sometimes they'll ask you this in your IGCSE. The structure of the question will be something like, explain in terms of molecules how conduction occurs, right? You're supposed to say that at the hot end, the particles will gain energy, vibrate, pass on energy to the adjacent molecules all the way until it reaches the cold end, guys. So it's essentially going to be something like that. Anyone's got any questions for this part here? Anyone don't understand anything I'm talking about or want me to repeat anything I just said? I assume 100% absorption rate, right? Then moving on to the next part here, this is essentially how convection occurs, guys. Now, in order to understand how convection occurs, you have to imagine yourself cooking Maggi mee, you know. Like we said before, right, for those who have never had the privilege of cooking your own Maggi mee, maybe it'll be a bit hard for you to imagine this. But essentially, if you ever cook Maggi mee before, right, you'll need a pot, right? And inside this pot, you need it to be filled with water, and then beneath this pot, you essentially start heating it up with any heating source. Could be your induction cooker, could be your normal gas stove, whatever it is, as long as you start heating up the thing, right? If you guys ever cooked Maggi mee before, right, have you ever noticed that as soon as the water reaches boiling point, guys, you'll notice that the bubbles of the water, right, they start kind of going towards the side of the pans. Why do you think this is happening? Now, the reason why this is happening is because there is essentially a convection current that is occurring inside this pan here itself, you know. And so how does this convection current occur? Let's just focus on 4 specific particles. Let's split this water into half. Let's say that I have a relatively hotter particle here and a relatively hotter particle here, because it is closer to the heat source, right? And let's just say that I have a relatively colder particle here and a relatively colder particle here, because they're essentially the furthest away from the heat source, right? Now, today, if you recall back about the chapter we learned from 2.2, we understand that heat is definitely going to cause things to expand, right? And because we understand that heat expands, these water molecules at the bottom here are no different as well. Today, as soon as we start providing heat energy to it, what's going to happen is, right, this thing is going to start vibrating and expanding into a larger volume, right? So because it expands into a larger volume, I know for a fact that the volume increases. Now, if the volume increases, right, according to my density formula, density which is equals to mass over volume, and I know for a fact that, even though I heat up any of the water molecules, the mass of one water molecule is never going to change, right? And because the mass was constant, whereas the volume is increasing, I know for a fact that the density is definitely going to drop, because density and volume are inversely proportional to each other, whereas density and mass are directly proportional to each other. Today, if the volume and density are inversely proportional to each other, it means to say that an increase in volume is going to decrease the density. So this is essentially what's happening here, because I start heating it up, it starts to expand and increase in volume, the density drops, and it starts floating towards the top. When it starts floating towards the top, right, it's not going to leave like an empty space. It's not going to leave like an empty space at the bottom here. That's definitely not going to be the case, right? When the hotter molecules go up, the colder molecules will go downwards and replace the hotter molecules. So what essentially happens is, right, the whole cycle starts repeating. When the colder molecules go down, right now they are right above the heating source. So yet again, the whole process is going to occur, right? The colder molecules gets heated, they expand, then they decrease in density, rise up, pushing down the relatively colder molecules, yet again, heat up, expand, rise up, heat up, and eventually there's going to be something known as convection current. This rise and fall of the hot and cold particles is something we call the convection current. Okay, so this is essentially what is going on here, guys. And this is the reason why from the top, when we view it, right, we see that the boiling water, they kind of push towards the side, right? Is because there is convection current occurring inside the pot itself. Do you guys get what I'm talking about? Anyone confused with anything I've talked about? Anyone's got any questions with this? This is quite important. If anything, I see this come out more often in your IGCSEs than not. So, anyone's got a question for this? Okay. So if there's no questions, moving on to this next part here, right? This is essentially what I've mentioned in a more structured format. Oh, what's this? Oh. Okay, so if you look at the statements here, they are quite self-explanatory at this point, right? Convection is the transfer of heat energy in liquid and gases, like I mentioned just now, right? When liquid is heated, its volume will expand and thus the density will decrease. Exactly like what I've mentioned just now, right? Because when you get heat up, the density decreases, it rises up, replacing the colder molecules downwards, and the whole process will start repeating itself again. Okay, now the water above the heat source becomes warmer, expands and rises as it becomes less dense. The cooler, more dense water sinks to the bottom of the beaker and then is heated. The circulation of warm and cold water sets up a circulating stream known as convection current. Now today, I mentioned that convection can occur in a liquid. It could also occur in a gas as well, guys. This is essentially how the wind from the earth is created, like the heat from the sun beams down onto the ground, which heats the air particles above the ground, causing it to rise to the top, displacing the colder air particles downwards, and then the whole process keeps happening again. This is essentially how wind is generated, guys. For those who are having a hard time imagining, for a very easy illustration, let's imagine this is the ground and this is the sun, right? When this sun beams down heat to these tar roads, right, what's going to happen is this place will become much hotter, and when it becomes much hotter, it will start to heat up the air particles above it. When it heats up the air particles above it, obviously it will become less dense and rise towards the top, displaced by the relatively colder air downwards. And because of this continuous stream of up and down hot and cold gas, this gives rise to wind, guys. Wind is essentially an application of conduction of what's it called, the convection current, guys. This is why wind is also from the source of wind is also from the sun, guys, because you need to heat up the ground and then raise the gas particles upwards. Okay, so if you look at these diagrams here, right, this is essentially what's happening in your Maggi mee pot, right? Because of this Maggi mee pot here, you cause it to rise and sink and rise and sink. That's why you can see the bubbles kind of go towards the side of the pot. This is the understanding of convection current also could explain tectonic movement as well, guys. We know for a fact that the core of Earth is very hot, right? And then on top is some layer of mantle and molten lava and whatnot, right? Because it's very hot, it will cause the relatively hotter particles to rise upwards and cause the relatively colder particles to sink at the bottom as well. That's why you can see that eventually over time they actually kind of bridge away, right? It's because of convection current happening at the mantle of the Earth as well, guys. And this gives rise to all the new mountains and new islands and essentially the continental drift as well, guys. So yeah, these are all the interesting applications that you could understand from the convection current here. Right. Anyone's got any questions from this part here? Okay, so moving on to the final part here, which is essentially going to be radiation. Now, today, if you talk about radiation, like I mentioned, radiation is the only form of heat transference that could travel from the sun to Earth through the vacuum, right? Now, radiation is quite interesting and easy to understand. Radiation is the transference of heat energy through light. When light is emitted, heat is present due to infrared. Guys, you're going to see this word very, very often in your IGCSEs, guys. And I just want you to understand that whenever you see the word infrared radiation, it is essentially the thing that is responsible for anything that is hot, guys. Anything that is hot is due to infrared radiation. You know, like a lot of people, they say that the sun is very bright, that's why it's very hot, right? That is not true, guys. If you must know, the sun actually emits three forms of electromagnetic waves. The first one is known as infrared radiation, the second one is known as visible light, and the third one is known as UV rays, guys. Infrared is the one that is responsible for the heat. That's why sometimes when you put your hand under the beaming light of the sun, it gets really, really hot, right? It's because there is infrared present. The reason why you can see that the sunlight is very bright is because there is a visible light there. And the reason why so many people, especially the guailos, right, they get skin cancer is because of the overexposure of UV ray radiation. UV is the one that is causing cancer to the skin cells, guys. Infrared hot, visible light, the one that you can see, right? The one that you can see, and this is essentially the thing that gives you cancer, right? You know, like some quailos, they even like to go to all the tanning saloons for all the UV scans just to tan their skins and everything, right? That is actually very bad, especially like overexposure. Like some quailos, they expose they go for sunbathing for 3-4 hours a day, which I think is a bit crazy lah. But you know, who am I to tell them how to live their life? You know, but yeah, just always remember this, guys. Whenever you see the word infrared, it is essentially responsible for anything that is hot, guys. The reason why it's hot in your oven is because there's infrared radiation. The reason why your stove is hot is because there's infrared radiation. Anything that is hot is due to infrared radiation, guys. Very important. Okay, light and infrared is part of the electromagnetic spectrum. All electromagnetic spectrum waves do not require a medium, meaning to say they can all travel in vacuum, guys. And finally, radiation is the only thermal transfer of energy that can travel through space. Yet again, indicating that it is the only one that can travel in a vacuum. All right, guys. Anyone's got any questions for this part here? Okay, then the final thing that we're supposed to learn about today is basically emitters and absorbers of heat. Now, emitters and absorbers of heat are essentially just playing around with the black, white, and silver materials, right? I think most of you guys have learned this in year 9 as well, but just for understanding sake, we know for a fact that black is generally the best absorber of heat, meaning to say, right, if let's say, for example, today, you and your friend decide to go to the beach, right, you being a man of physics or a girl of physics, right, you'll essentially wear a white color t-shirt here. Oh God. And your friend being maybe a not so man of physics or even maybe an idiot, is actually going to wear a black color t-shirt here, right, a black color t-shirt here. Oversimplified black color t-shirt, but you guys get the idea, right? So essentially what's going to happen is, right, when your friend is at the beach wearing this black color t-shirt, he is actually going to feel much hotter, much faster. Why? Because in general, black is a good absorber of heat, meaning to say heat from the sun now is essentially being absorbed by the t-shirt, and it is also a good emitter of heat, meaning to say it's going to emit it into your body, causing you to feel hot. Whereas a white color in general is a good reflector of heat, meaning to say, right, even though the same amount of heat energy is shined upon to this guy here, this white color will reflect most of the heat. It will reflect most of the heat here, but of course, it's not the perfect reflector of heat, right? It will still have some heat being emitted inwards, right, and absorbed, right? But is essentially going to be much, much less compared to the black color t-shirt, because in general, white is a good absorber, bad absorber, I mean, a bad absorber of heat, a good reflector of heat, and in general, a bad emitter of heat. Whereas black color is the total opposite. It's the good absorber of heat, bad reflector of heat, and also a good emitter of heat. Now, guys, when we talk about emitting heat, guys, it's basically like radiating heat outwards, guys. The black color things will usually emit much more heat, meaning to say, right, if let's say today I have one metal stick versus another metal stick. Let's say I heat it up. I heat it up into 100 degrees Celsius, and this one will be 100 degrees Celsius as well. This is black and this is white color. What I mean when I say is a good emitter of heat, it means to say that this black color will usually emit heat much better compared to this white color one here, guys. It does not emit heat outwards as well as the black color. This also means to say that black color will have its temperature drop much faster because it is emitting most of the heat outwards much faster compared to white in color, guys. And this is essentially what we mean by emitters of heat, guys. Anyone's got any questions for this part here? So if you look at this simple example here, it's quite self-explanatory as well. Emitters are generally things that give out heat, right? Absorbers are the things that generally take in heat, guys. You can see here that black is actually the best emitter of heat, worst reflector of heat, and also the best absorber of heat. Whereas silver is the worst emitter of heat, the best reflector of heat, and also the worst absorber of heat, guys. And because of this, guys, if you ever had your parents park in the open air before, guys, usually you see that, you know, the windscreen, they have this silver thing that reflects the heat. It's essentially, the concept here is very simple. They want to put the silver thing on the windscreen so that the heat that is coming through the windscreen will be reflected outwards as well, guys, so that essentially kind of cools the air, cools the car, interior of the car a little bit more, right? So this is essentially what is going on, guys. Emitters and absorbers of heat. And finally, this is one of the most common examples in your IGCSE to test whether it is a good emitter of heat or also a bad emitter of heat. This experiment is a very simple one. What essentially happens is, right, there will be initially a hole here where we can pour hot water into this cube here, right? And on this cube, we'll paint each side different colors. One side we paint it black color, one side we paint it white color, and one side we're going to paint it silver color. After the hot water was poured into this cube, we'll let the heat settle down for a while. And then we're going to take a thermal gun, guys. We're going to take a thermal gun to scan each and every one side of this box here, right? And what we find is that when we scan the white surface, the temperature maybe, let's say the temperature was 90 degrees Celsius. The silver color one, because it being the worst emitter of heat, right, maybe it will be somewhere around 89.5 degrees Celsius. And black color, being the best emitter of heat, maybe it will be somewhere around 90.5 degrees Celsius. From here, we can tell that different colors or different colors will have different emission of heat. And because they are better absorbers and emitters of heat, black color will generally be higher temperature, whereas silver color will be much less temperature. But the difference in temperature is going to be very, very little only, guys. It's not like this black color is 100 degrees Celsius and this is like 50 degrees Celsius. It is not that case, guys. It cannot be the case because, yet again, thermal equilibrium is a thing, guys. How can your hot water justify supplying 100 degrees Celsius here and only 50 degrees Celsius here? It doesn't quite make sense, right? So be very careful with this, guys. Usually when we use a thermal gun here, we must use a very sensitive thermal gun. Why? Because the difference in temperature is very, very small only. And because the difference is very, very small, if you don't have a sensitive enough thermal gun, you won't even be able to read the difference in the temperature, guys. Anyone clear with what I've talked about? Yeah, so this is essentially all the things you should know for everything here. Guys, anyone's got any questions with this part here? Anything you don't understand at all from this chapter? Anything you want me to repeat? Okay, if there's no questions here, let me send you guys some Google Sheet questions so that I can monitor your answers here, guys. Everyone do these two right now before your class ends. Do the first two link before your class ends on WhatsApp, right? And then the other two links as homework. Oh God, I sent this wrong. Wait, I'll do the first two links first, guys. Yeah, do the first two link. These two link. The first two are guys, which is essentially going to lead you here, guys. Let me open up the screen here. You're supposed to be led to these two links, guys. Do this right now before you leave home, before you leave class, right? For those who have completed these first two, you would have earned your freedom. And then, guys, I want you guys to do homework, guys. You see the notes that we just completed, right? Actually, let me share back my screen here. Shit. Why is it taking so long? Oh, right. Let me send this to you as well. Oh, Jesus. Yeah. First two links. You're not in the WhatsApp group. I keep forgetting. These two links are supposed to be your homework. Maybe you want to save this down. Then, what the hell? Whatever. Stupid Zoom. Guys, you see, we just finished this here, right? Just now, right? You see all these exercises all the way at the bottom until you can see some GG Easy Life, right? Finish everything as homework, guys. We are going to discuss the answers for everything on this notebook next week. But right now, before you guys go, I want you guys to do the Google Sheet questions. Finish 2.3.1, finish 2.3.2 before you end the day, guys. I can monitor here. So yeah, start doing it right now, guys. I've sent it to the Zoom chat. The first two links are going to be your homework, guys. All right. I mean, the first two links is what you're supposed to do right now. The second two links are supposed to be your homework as well. So start doing it now, boys and girls. I'll be right back. Gonna go to the toilet. Okay. How's the response so far? Oh, Leha, not doing too well. Jihin, very good. Raj is doing well as well. Jaden, where's my response? Ah, there it is. Not too bad. Quite good. All right. For those who are done with this, you need to do one more, guys. The second one before you can earn your freedom and get out of here. Oh, this guy is done already. Very good. Hey, Jihin, you want to do the third and the fourth one as well, since you're so ahead of time? Guys, if you don't understand anything from this question and you don't understand the feedback as well.
Which one is the third one?
Sorry?
Which one is the third one?
I sent in the link already. Oh my God.
I think the third one and the second one is the same link.
Is it? Let me send it again. GG. Oh, you're right. It is. Thank you. Thank you for pointing that out. Let's send this to Raj as well. Here. Isn't it to Zoom and Google already? I mean, Zoom and WhatsApp already, guys. Guys, if you don't understand anything, make sure you ask some questions, guys. Don't just stay silent. It's definitely not going to help. Oh, Raj, excellent job. Yeah. For those who are done with these two already, and if you have another class at 12 o'clock, you can go now. But for those who are not even done with the second one, make sure you do the second one before you leave.
I leave.
Yeah, you can. But make sure you finish the rest of these two as well.
I finished the third one. Later I do the.
Okay, yeah, sure. Just make sure you do everything. Good. All right, bye, man.
Mr. Gabriel,
Yep.
can you explain 2.3.2 question 1?
Question 1 certainly was this. Which process occurs in a metal to cause thermal conduction? Okay, like I mentioned just now, right? Conduction occurs because there is free moving electrons, right? And for conduction to occur, the molecules must vibrate and pass on energy to the adjacent molecule, right? So looking at this situation here, electrons transfer, which is essentially free moving electrons. This must be it. Proton transfer, there's no such thing, right? It's just like a scam to scam you students. So this one is for sure not. Lattice vibration is a must because for conduction to occur, it must vibrate, pass on energy, vibrate, pass on energy, vibrate, pass on energy. Am I right? So if I'm not mistaken, C should be the answer for this one. Yeah. You understand what I'm talking about, Leha?
Yeah.
Yeah. All right. Jaden, not bad as well. 4 out of 5 already. Yes, you have earned your freedom as well, Jaden. Make sure to do all the homework. Okay, I'll see you. Oh, Leha, you're struggling a little bit with this chapter. I see that you're getting 2 out of 5 for both papers also. Are you okay? Anything you don't understand?
I'm not sure about question 2 and 4. Yeah.
Okay, let's go through question 2 real quick since you're the only one here right now. 2 otherwise identical cars, one black and one white, are at the same initial temperature. The cars are left in the bright sunlight and their temperature increases. During their night, the temperature decreases. Which car shows the greater rate of temperature increase and which car shows the greater rate of temperature decrease? Your answer was B. Black increases more for sure because black is a better absorber, but you wrote white being a greater decrease. Now, if you think back about this, a greater decrease in temperature is because it is emitting heat outwards, right? And which color is the one that is the better emitter of heat?
Black.
Yeah, that's why the answer should be A. A lot of students, they always choose black and white B here, but in reality, you have to always remember that for temperature to decrease, the heat must be emitted out from the black color car, right? So obviously black and black is the answer in this situation here. You get what I mean?
Yeah.
Yeah, and then after that, question 4, what's this? A diagram shows a cooling unit in the refrigerator. Why is the cooling unit placed at the top? Now, if you think back about how convection current occurs, let's imagine today, for some reason, I decide to put the cooling unit at the bottom here. Because we know for a fact that heat goes upwards and the cold particles is supposed to come downwards, right? You understand this concept here, right?
Yeah.
Right. So if let's say my cooling unit is at the bottom, the colder particles that it causes to cool down will always forever stick to the bottom. So the hotter particles will always remain at the top. And this is essentially the reason why our aircon units are always on top. And if you go to the Western countries, the heaters are at the bottom. Usually in a normal arrangement, the aircon units will be at the top and the heaters will be at the bottom because I want the cold air to circulate downwards and I want the hot air to circulate upwards. Do you understand what I'm talking about?
Yeah.
Yeah, so if you can understand this, then looking at the question here, what do they want? Why is the cool unit placed on top? Your answer was cool air is a bad conductor. So heat is not conducted in the refrigerator. Not exactly, right? Cold air falls and warm air is displaced upwards, right? The A should have been the answer here, ma. You understand?
Yeah.
Yeah. All right. Any other questions that you need explanation? Question 3, okay, this one.
Question 3, I realized I didn't do it.
Yeah, try to read the feedback and logic answer behind, like backwards. Okay.
Yeah.
All right. Any other questions, Leha?
No.
All right, then I'll see you next week.
Okay, thank you.
Welcome. Bye.